My first name is L-E-I.
All right, you guys ready? I'm ready to start. I got it going already. All right, you guys tell me. Actually, I'm going to grab one more thing here while you guys are finishing up. You guys got to tell me where you want to start. From the beginning, you want me to start with number 3? Okay. Just so you know, I did look, and if you go to the old Weebly website, and I'll try to put a link up on the haiku, there is a video from last year, in case we don't get through everything. And the multiple choice is up there, too, in case I don't get it up right away after school. Okay? All right. We're going to do that at the end. So I'm going to try to do half an hour of this, okay? And we'll talk about C's at the end. All right. No. Find the calculus is more interesting than that. All right. Find the value of the derivative if it exists at each indicated extremum. So basically, we got to take the derivative of this thing. And this seems like the wrong stuff, doesn't it? I think this is the wrong PowerPoint. We were in... No, that's the right one. Hints. Okay. Oh, maybe it was... Yeah, okay, we're fine. I just didn't recognize the problem. Okay, so I got to take the derivative. What rule am I going to need for that particular derivative? What rule do I need?
Quotient rule.
Quotient rule. So we're taking the derivative. So, low D high. Low. Ah. Yeah, well, give it a second. It'll come back. All right, low. What's the derivative of the high? Let's go back. What's the derivative of the high? I turned that on because we might need it. All right, 2x minus the low, or the minus high, which was x squared. What's the derivative of the low? 2x over the low squared. Now, this is one of those ones, do not try to simplify it. They want you to plug in a number. So what number are you going to plug in? 0. It told you on the graph. So f prime of 0 equals, so let's see. 0 squared is going to be 0, so 4. 2 times 0 is 0. Minus 0 times 0 over 0 plus 4 squared. So what's the answer going to be? Isn't it 0 on the top over 16? So 0? Okay. All right. And just so you know, Mr. Lepis will be here this afternoon from 3 to 5. So you're welcome to go down to his room to get more help after school today.
We were in tutorial groups yesterday, and they learned that, you know how you do that sign chart, like positive, they do it way different.
That's okay. Does our way work?
Yes.
Yeah. You can go with my way.
Bella, can you go back real quick?
Yeah, I can go back. All right, so we're supposed to find any critical numbers. To get critical numbers, what do we need to do? Derivative. Before I do a derivative of this one, though, I'm going to rewrite it as 4 minus t to the 1/2 power. So we've got g prime of t equals, what rule am I going to need in here first? Product. So keep the first. Derivative of the second would be bring the 1/2 in front. 4 minus t to the what power? Negative 1/2, but be careful, there's a chain rule in there. What's the chain rule going to give us? The 4 is going to go away. It'll give you a -1, so I'm just going to make that 1/2 negative. Plus, keep the second, which is the 4 minus t to the 1/2 power. Derivative of the first is what? 1. All right, because we're supposed to find critical numbers, so I have to eventually get it equal to 0, so I'm going to try to simplify that a little bit before I do the equal to 0. The numerator of this would be -t. This is going to get thrown to the denominator. So I've got a 2, and I'm going to make it a square root instead of the 1/2 power. Plus square root of 4 minus t. And we said to get critical numbers, we're going to set it equal to 0. It looks awful right now. It's really not that bad. Okay? I know. But watch what happens. I'm going to take this and move it to the other side by subtracting. So t over 2 square root of 4t, 4 minus t, square root equals square root of 4 minus t. Yes, and it's negative. Thank you. All right. What's going to happen with the negatives ultimately? Yeah, they're going to go, because I'm going to divide one negative over, it's going to make it go positive. So the negatives are gone. We're not going to deal with that anymore. Okay? All right, now remember we got to multiply this thing to the other side. So what's going to happen is I have t equals 2, what's a radical times itself? Whatever's underneath the radical. So the radical went away. See how it looks scary, but it's not? All right, what are we going to do with that 2? Distribute. So 8 minus 2t. I got to get the 2t to the other side. How are we going to do that? Add it. So 3t. So t is equal to 8/3 would be our critical number. Where's the other place we get a critical number from? The denominator. So I could really quick look at that denominator. Notice t has to be less than 3, so we got to make sure it fits in there. So I'm taking that denominator. I really don't need the 2 because it's going to go away. I square both sides. I've got negative t equals negative 4, so t equals 4. Do you see how 4 is outside the domain? Yeah. So if this was multiple choice, you wouldn't need it. You wouldn't see that as an answer. Or if it was an answer, it'd be a wrong answer. Okay? And it's because of the domain restriction. All right, I know this next one, number 28, for sure is on the test. Okay? Because I was looking at the test. I think it might even be on the calculator. There were 3 calculator questions. Remember, you're going to have to number your paper, so you need to be here on time tomorrow, if not early. Okay? Ah, come on. There we go. Okay.
I seen the goal.
All right. No, we're not over. All right, so we're looking at the absolute extrema from this function. So absolute extrema, I need to put in the endpoints and any critical points. So I'm going to start by taking the derivative to find my critical points. And again, I think this is like one of the first couple problems on the test, so you got to be able to do this one. Okay, it's there. So I'm going to keep the low d high. So low is the x squared plus 1. What's the derivative of the high? 2. Minus the high, which is 2x. What's the derivative of the low? 2x all over the low squared. All right, because I do need to set it equal to 0, I would probably simplify this time, okay? So I'm going to distribute there. I've got 2x squared plus 2 minus 4x squared. Does that sound right? All right, and then we've got 2x squared and negative 4x is what? Negative 2x squared plus 2 over x squared plus 1 squared. Morning. All right, to get critical points, we set it equal to 0. Okay. So what's going to happen with the denominator when I multiply? It's going to go away, right? Because it's 0. So I've got negative 2x squared plus 2 equals 0. So negative 2x squared equals negative 2. X squared equals what? When I divide? 1. Good. And then we take the square root. We need to make sure we do a plus or minus. So x equals plus or minus 1. So remember, absolute works different than relative. Okay? So when we have absolute, you plug in your endpoints, and you plug in anything that could be a possible critical point. So I'm plugging in to my original function. All right? So I'm going to plug in f of negative 2, f of negative 1, f of 1, and f of 2. Does everybody see where I got those numbers from? Endpoints and what we solved here. Okay, absolute, you include the endpoints. That's the big difference. All right, negative 2, I'm plugging into this right here. So what's negative 2 times 2? Negative 4, and then negative 2 squared is? 4 plus 1 is? 5. Okay, so I did all that work in my head. We're plugging in a negative 1 next. So 2 times negative 1 is? Negative 2. Negative 1 squared is? 1 plus 1 is? 2, which is really equal to negative 1. All right, I'm putting in a positive 1. 2 times 1 is 2. 1 squared is?
One,
Plus 1 is?
two,
2, so that's positive 1.
Bless you.
All right, putting in a 2. 2 times 2 is? 4. 2 squared? 4 plus 1 is? 5. All right, so what's your min and what's your max?
your mean,
Min is -4, 5. I mean, -1.
Absolute min would be the -1, wouldn't it?
Oh, yeah.
That's your smallest y value. What's your absolute max? 1, absolute max. 4/5 is smaller than 1, but you want the biggest number and the smallest number. That's a -1, right? 4/5, it would be -1, -4/5, 4/5, 1, wouldn't it? If we were looking at it on a number line. All right, ready for the next one? All right, I know the next one is on as well, okay? So there's going to be one where you have to do rolls and where you have to do mean value, okay? So you need to make sure you understand the difference between the two. So we're supposed to determine if rolls works. So this is the one, rolls, we start, well, both of them, we start by plugging in our endpoints into the original. So I'm going to find f of 1 and f of 4. So f of 1, I'm plugging into this thing here. What's 1 squared? 1 times -5. So 1 minus 5 plus 4 equals 0. Okay. Putting in a 4. What's 4 squared? 16 minus 4 times -5. 20 plus 4 equals. So because they match, am I using rolls or mean value? Rolls. Technically, you're supposed to write this, but if it's, I think actually you have to write it out. So make sure you write that down there, rolls. And then to use rolls, we take the derivative and set it equal to what? 0. All right, so let's take the derivative of the thing. What's the derivative of our original there? Good. Set it equal to 0. So 2x equals 5. X equals 5 over 2, which is really this what they consider the C value. Oh, don't box it. Look at that. I almost did it. Okay.
So on our test, we don't box them. Like,
No, it's okay. You don't have to box them. We're practicing the habit, right?
no, I mean, the test on tomorrow.
You don't need to box it. I'll look for the answer if I need to. Okay? All right, you ready for the next one? So if that was rolls, the next one better be mean value, right? And it's probably not going to tell you in the instructions. It might say you have to determine if it's mean value or rolls and use the right one. Okay? So to do rolls, remember we take and we plug in the endpoints, just like, or mean value, we plug in the endpoints, and they shouldn't be equal. That's when we know to use mean value. So we're going to plug in f of -2. What's -2 squared? 4. And then f of 1 and 1 squared is 1. So is it mean value or rolls? It's mean value, and you can abbreviate MVT. So in order to do mean value theorem, and I do have the little theorem hanging up there. I'll move the other poster maybe tomorrow, but this is it right here. That's what the poster says. Okay? So I need to take my I need to find the slope, and I need to set it equal to the derivative, right? So evaluate, or just set it equal to the derivative at. Oh, okay. Let's take our derivatives. Let's start there. So f prime of x equals what? 2x. Okay, I have to take that derivative and set it equal to the slope. So let's calculate the slope. Don't I have the points right here? Yeah. So my slope would be, what are the y values? 4 minus 1, and then the x values would be?
-2.
Good. So 4 minus 1 is? 3 over -3 equals -1. So I'm going to take that -1, set it equal to the derivative. So what's your x or your c value this time? -1/2. All right. Pretty much the rest of the test is all the stuff we did on the posters, right? So you've got your critical numbers, your open intervals, increasing, decreasing, first derivative, and then there might, and relative extrema, you might go to concavity on some of it. Okay? All right. So notice also there's this little sentence frame that we need to fill in, right? So that will probably be somewhere on the test for you to do. Okay? Huh? It'll be printed out on the test, so you got to fill in the blanks, okay? All right, so we are going to start by it says find the critical numbers. How do we do the critical numbers? Take the derivative. Good. So f prime of x equals, what's the derivative of that function? Plus 4. And I'm going to set that equal to what? 0. Good. So negative 4x equals... Negative 4x equals 1. Okay, now I have to determine, that was part A, the critical point. I have to determine if the critical point is where it's increasing, decreasing, and if it's a max or a min. Okay? So, I'm going to go use my sign chart. And again, other students on this campus may do this differently, and that's okay. Ours is good. Okay? I've gotten this down pretty well over the years, okay, on how to teach it well. All right, so I've got to pick a number that's less than 1. So what am I going to pick? 0 works great, okay? So I'm plugging 0 into the derivative. When I plug 0 in, do I get a positive or a negative? Positive. Awesome. All right, what's bigger than 1? 10. And remember, these aren't the intervals. Those are just numbers we're picking. That's why I try to write them really tiny, okay? I put in a 10, I get a negative 40 plus 4, positive or negative? Negative. So we got to talk about increasing and decreasing. So where's the function increasing? And if it helps you to write this on there, write that on there. Okay? All right, what about decreasing? And don't worry about open and close. They're always going to be open. Okay? So I'm not messing with the open close stuff, just open. All right, we're going from a positive to a negative. So is it a max or a min? Max. So if you see the sentence frame, do I need the one for min? No, I just need the one for max. So relative max at x equals 1 because f prime changes from what to what? Positive to negative.
Wait, will it always be F1?
Yes, it's always going to be f prime. And I'm forcing you to do that because that's the reason you need to write on the AP tests. Okay, so we're learning it now, so it's old hat when we get to doing the AP test. Okay? They ask you to justify your answer, and that's the justification they're looking for. All right, we good with 19? All right, it looks like this next one we're doing on the calculator, okay? So, or we can do on the, let's do it on the calculator so we make sure we know how to do it on the calculator when it comes time for the test, okay? If you didn't grab one, and let's practice this real quick. So go to your scratch pad. Let's get it typed in. It was 2x cubed. All right, and then plus 3x squared. And then minus 12x. And hit enter. Now, I like to turn off the original graph and turn on the derivative graph. So I need to get the derivative graph in there. Where do I go to get the derivative? The button next to the book, right? And then I grab my derivative here. And then we put in an x. And I have to put in where the original graph is. So I do var f1 of x. 2x cubed plus 3x squared minus 12x. I'll put the original back up. There's the original. You didn't get it yet. Okay, what's the next thing I should calculate? The zeros. Okay, so I'm going to go to, we do that by hitting menu, analyze graph, 0. I'm going to go to the left and to the right. This one's coming out nice. It probably would have been an okay one to do by hand, but I wanted to make sure we practiced one on the calculator for you. All right, I'm going to sketch that into our PowerPoint here. All right. I'm going to give you about 30 seconds to get caught back up with where I'm at, and then we'll get moving on this again so we get through some more. Okay, we ready? So, in part A, it's asking me find the critical numbers. So what are the two critical numbers? -2 and 1, the zeros, right? Okay, then on B, I'm going to draw my sign chart because I think it's easier to deal with the sign chart, transfer the graph to a sign chart. So I'm going to put my critical numbers on there. Am I above the axis or below the axis? Above to begin with, then what happens? Below, and then above. So, where is the original function increasing? Negative infinity to -2, and where else? 1 to infinity. Where's the original function decreasing? -2 to 1. All right, so I have both a max and a min, right? The first one is a what? Max, and then negative to positive is a min. So I know my max is at -2, my min is at 1. Because, what always goes after because? F prime. Okay? In the maximum, it always changes from what to what? Positive, negative. In the minimum, it always changes from negative to positive. So, you could almost fill this back part in and not have to mess with, and not have to, and it's basically memorized, right? You can do it from thinking, though. That works too. All right. We good with 21? Okay. Let's look at 41 real quick. Let's see what we're doing on time. Actually, let's go to, I know that's a trig one, but let's see if we can get below that a little bit. Because we've already done some max min ones. Let's go to, that one is on a video somewhere. So, because I'm looking at last year's notes. All right, let's look at the graphing. We're supposed to sketch the derivative of the graph, okay? It's probably going to be a matching kind of thing on the test, so you're going to have to match the right one. So if this is the original, where are the critical points? -2, 2, and 0. Okay, and we get that from the horizontal tangent. So on the original, you're looking at your horizontal tangents to get your zeros. That's where the slope is 0. All right, is the original graph increasing or decreasing first? Increasing or decreasing? Decreasing. Okay, so is the derivative going to be above the axis or below? Below the axis. Okay. Then I switch to increasing or decreasing? Increasing. So my derivative is going to be above the graph. All right, then I switch to decreasing. So am I going to go above or below? Below. And then increasing or decreasing? Increasing, so above or below? Above. That's it. All right. What you have to be careful on is to make sure you read the instructions, because looking at the next one, it says they give us the graph of what? F prime, and we need to identify increasing and decreasing, and then any maxes or mins. Okay? So the best thing to do whenever you have the draw the sign chart, right? It's the easiest way to go. So what are my critical values? Notice I'm looking at my zeros because I'm on my derivative graph. -1, 0, 1. Good. All right. Am I above to begin or below? Above, and then what do I go do? Below, and then above, and then below. It doesn't always go back and forth, okay? So don't count on it. A lot of times it does, but not always. All right, the part A said increasing or decreasing, so where is it increasing? What intervals? And 0 to 1, okay? And then decreasing goes where? -1 to 0 and 1 to infinity. All right, part B wanted us to talk about our maxes and our mins. So we've got a relative, let's see, that is going to be a max or a min there. Max. What about here? Min, right? Positive to negative slope is going to be a max. So I would say there's a relative max at x equals -1 and +1, and a relative min at x equals, and notice, it didn't give us the little explanation thing, so likely it's going to be something that is a multiple choice. Okay. All right, I'm going to skip down to the some concavity, so we at least get one of those in. Does that sound good? Okay. So we probably have time for about one more here. All right, so if I go to that one right there, we have to do points of inflection and concavity from it. So where do I get points of inflection and concavity from? Second derivative. Okay, so I have to do the first derivative first. So what's the first derivative of this? Plus 12. Okay, and then I'm going to go to the second derivative, and we end up with what? Minus 12 equals 0. All right, so 6x equals 12x equals 2. All right, so for point of inflection, it depends. Sometimes they just want the x value. Sometimes, so if they don't just want the x value, they want the y value, what are you going to do? You'd plug it back in. I'm going to trust that you could do that. Okay. Let's talk, though, about the concavity piece and really verify that it is a point of inflection. Okay, that's more important. So I'm going to use my second derivative. Okay. So what am I going to put in that's less than 2? I would have probably chosen 0. Okay. So when I put a 0 in here, what do I get? A negative. Good. And then what is bigger than 2? 10. Perfect. All right. When I put a 10 in, what do I get? Positive or negative? Positive. All right. So where is it concave up like a cup? 2 to infinity. All right. Where is it concave down like a frown? Negative infinity to 2. Okay. All right. Let's see if I can do, let's see what else we got here. I'm not worried about second derivative test. Let's do one more. 12. We've already done that. It's the same thing. Okay. Let's do one more here. Let's do this one. Not that. I'm not worried about second derivative test. All right. Let's look at this one here. Okay. And then we'll talk about the fundraising. So the graph F is shown. They want us to graph F, F prime, and F double prime on the same set of axes. Remember the derivative dance when you're thinking about these things. Okay? All right. Remember it has to go down by one hump every time, right? But you also remember we have other stuff now. Where's the, this is the original, where's the 0 for the derivative? 1. So I'm going to plot that there. Okay? Is it increasing or decreasing first? Decreasing, which means my derivative is above or below? Below. See how we know more than we did the last time we did this? Okay. And now am I increasing or decreasing? Increasing. So am I above or below? Above. And then we know that the line, this is F prime, the line always goes to what afterwards? A horizontal. Is this increasing or decreasing right here? Increasing. So should it be above the axis or below the axis? Above the axis would be F double prime. Okay?
So how do you know where F double prime is? You just pick a random
You pick a random point. It should represent it should be a representation of the slope. So if the slope was 2, I should graph it at 2. If the slope was 1, and I really can't tell from what I've graphed, right? So pick something that's above. Likely you're going to be picking a multiple choice, right? All right, we good with that one? All right, we got the majority of them done, I think. Okay, let's talk about where we are with fundraising, okay? So, really quickly, because I got to get this out today. So, right now, our goal has gone down a little bit because we lost a few people, which made us lose a bus. So we don't have to pay for 3 buses. We only have to pay for 2, okay? Because we can do a bus and 2 vans right now. We've lost a few here and there. So a few here and there are translated to less money. So, okay. So the current amount that's in our account is about $8,000, and that is from the cookie dough, the concessions, and what we had left over from last year. Okay, because we had a chunk left from last year. So we're down to $9,400. That's way ahead of where we were last year. Okay, that means less fruit snacks. All right. Trust me, we sold a lot of fruit snacks last year. It was obnoxious how many fruit snacks we sold. So the total we have left, it was at $140 a student, and now it's down to about $79 a student. But that doesn't mean you just pay $79. If you have done nothing, you still should be at $140, right? Because we have people who have done nothing, all right? So this is kind of where we are at. Okay? Your class won the donuts, so tomorrow morning you'll have donuts for your test. Another incentive to get here early, right? Because you'll get the donut that you want. All right? Lee has won dinner because she sold 37. So 37 out of the 80 was Lee. Okay? She did an excellent job. Okay? So for right now, for you guys, you did a great job selling cookie dough. You guys had a 60% participation. Lepus was right behind you. The first period Lepus class was right behind you. Okay? So that's awesome. Okay? You got to keep that up. And remember, everybody does their part. Some of you guys work snack bars, great. Some of you guys sell cookie dough and seize candy, great. Every little bit helps. Next week we have the carnival coming up, okay? So we'll talk about that probably Monday. These are the people who've been working concessions. I really appreciate that. Notice, this is Ballard's classes and concessions, okay? So I'm hoping the other teachers get on theirs a little bit. But you guys have done a great job. You guys are kind of tied with 5th period on people showing up to do concessions. So, huh?
They're both 3 classes.
They're both my classes, yeah. So, well, I'm in your face about it a lot. So, all right. So, yeah. Huh? Is it not up there, right? Oh, sorry. I will. All right. So here's the problem. When we did the cookie dough, 64 people out of 120 didn't participate. That's more than half, right? You guys, it isn't as big of a deal because most of you did, but just so you know, you got to put pressure on your buddies in other classes. So if the pattern continues, we won't make it, okay? So don't expect to do no fundraising and still get to go. If we don't make it, the entire group will not get to go and it'll go to next year's class, which we don't want that to happen, okay? So remember, we all go or none of us go. You need to help with something, whether it's seize candy or concessions. We have a lot of concessions coming up with the water polo girls, okay? So here's your goal for Christmas seize candy. So you want to try to sell between 5 and 10 items. We usually get about $2 to $4 an item. But the more we sell, the more profit Seize gives us. So if we sell over a certain dollar amount, if we sell over $2,000, we get more money back, okay? If you didn't sell cookie dough, you want to try to sell more like 10 items, okay? Money and the order is due Tuesday, November 29th. You're going to take it to Joy just like you did last time, okay? Checks still to THSASB. We would expect delivery about the week of December 14th. I think I put the 12th to whatever the week is of finals, okay? We will try to get an online option going here. I haven't talked to Joy about that. But here's the deal. It's going to be really quick. You have to turn it in this day because I'm giving you over Thanksgiving, because don't you see a lot of family over Thanksgiving? Sell to them. All right? I'm not done yet. Shh. I'm not done yet. Okay? It makes great gifts. We'll have it. It comes in Christmas wrapping paper. It's a high-quality product. There's members to sell to. Teachers and staff get inundated, so they're willing to help, but make sure you're polite to them. Okay, you guys are getting this first. We always take donations. If you want to pay down by a donation, that's okay. All right, instead of selling teas, you want to donate some money, pay a little bit of money. Put 20 bucks in or 40 bucks in, okay? If you sell 20 items, you can get a free mini box. Top overall will get Disneyland. Top in each class gets a $5 gift card. Class who sells the most will get donuts. So you could earn donuts for finals if you guys sold the most again. Okay? All right, you guys can go. I know there was like one of you. Lee didn't get hers.
Mother, do you want to buy some Seize candy?
I will towards the end. Okay? And Sage didn't get hers.
Sorry.
Okay? Sage, there's yours. Lee, here's yours. I know church ladies like candy. And this doesn't melt.
Right.
Well, because it won't be as hot.
I literally had like, we did